All right, so to start today, we're going to take a look at these three graphs, and we're going to find the domain and range. The first thing I want to know is which one of these is a parabola? Which one of these is a parabola? Number 3. Number 2 is not a parabola, okay? Correct, because parabolas are functions. Now, I don't know if you remember, we talked about the vertical line test. You remember how we talked about if a vertical line could pass over a graph? And it's only allowed to touch it at one point at a time, yes? So if I do the first one, this one definitely is a function, yes? If I do the last one, this one definitely is a function, yes? But this one is not a function because if I draw a vertical line on there, it would touch it at 2 points, meaning it's not a parabola if it's sideways. Is everybody all right with that? Yes? No, the square root graph is a function. The square root graph would just be half of this, like that. Okay. All right, so let's start over here and let's talk about domain. Domain is the x's. X's travel left and right. Does this thing go to the left, to the right, or both? Both, so my domain is all real numbers, yes, the funny looking R. Sorry. Range talks about the y's. Does this thing go up, down, or both? It only goes down. If it only goes down, it has a very highest point, which means all of the y's will be less than or equal to the y value up there, which Savannah has corrected as 2. Okay. Number 2, let's talk domain. Does this thing go to the left, to the right, or both? Only goes to the right, which means this point right here is as far to the left as I will go. So the x's are either greater than or less than that point. Greater than or equal to, and what is the x right there? 1. Wonderful. The range. Does this thing go up, down, or both? Goes up this way and goes down this way, doesn't it? So the range is all real numbers because it goes both ways. How we doing? Yeah? Last one here should be pretty easy because this is what we've been used to. What's my domain here? How about my range? And equal to -4. Questions for me on domain and range? Go ahead. Are we what? Are you sure you're all right? Okay. All right. So let's go ahead and recap what we did yesterday. Yesterday, we talked about normally to solve an equation, what do I have to do with my variable? Normally, I have to isolate it. But in some of these problems, how many kinds of variables are there? 2. 2. Which means I cannot isolate them because there's 2 different types. Okay? When we have that, you have to do the factoring that we all love so dearly. Okay? But yesterday, I showed you that solutions to quadratic equations can be called many different things. On a graph, if I'm looking for a solution, where are you looking? The x what? The x-intercept. That's what we did yesterday. Okay? If I'm looking for a solution, a root, a 0, it's an x-intercept. Okay, remember we talked about all 3 of those things meaning the same thing yesterday. And yesterday we actually started out doing the more difficult way where we factor them, and then I showed you that an alternative to that is graphing. Is everybody okay with this? Just recapping from yesterday. Fair enough? All right. Today we're going to do some application problems of this, and we've already done them. You just have to know what you're looking at on the graph. Now, my problem with the first 3 is I don't have any equations for you. So you have to make your own equations. It says find 2 numbers that have a sum of 17. What does sum mean to do? Add. So what can I write for an equation? Well, how do I know what numbers they are? What are you going to use for something plus something? X plus y will equal 17. It also tells me the product of those numbers is 60. So that would be what? How's everybody doing here? Is everybody all right with this? Now, before you start typing away, please give me your attention, because yesterday when we solved these, okay, again, give me your attention, please. Yesterday when we solved these, we were looking for x-intercepts because they were quadratic equations. They made U-shapes, didn't they? Because the highest power was 2. Do I have anything here with the highest power of 2? No, so we're not going to be looking for the same thing here, folks. How many equations do I have? That means it's called a system of equations. Do you remember hearing that phrase a while back? A system means 2 equations solved at the same time. So on a graph, what are you looking for? If you have 2 equations solved at the same time, where they cross. So when you put this in, we're looking for where they intersect. Go ahead. It's a little bit different looking, right? Yeah. One of them should be familiar to you. One of them is a line, right? Which one is the line, the first one or the second one? The first one's a line, because if it's linear, I cannot have multiplication of variables, and you can definitely see there's multiplication of variables here. So how many times do these things intersect? Twice. But look at the numbers in both points. Aren't they the same numbers? Because if I do 5 plus 12, is that thing the same as 12 plus 5? Yes, so my two numbers here are 5 and 12. Those are the two numbers that satisfy this problem. Does anybody have any issues typing this in and seeing what I'm looking for? Now there's 2 at the same time, so I want where they cross. Okay, you're just looking for something different. Correct. Number 2. Now I have the sum of 2 numbers that is 10. Can you tell me the other equation before we do that? And you're telling me what are the numbers, Derek? -4 and 14. No matter what the 2 points are that you're looking at, they should be the same. Is that all right for everybody? Does anybody have any questions on this? Okay. Now I have the sum of 2 numbers is -5. And their product is 36. -9 and 4. Okay, so I'm pretty sure I got Derek and Savannah with me. How are the rest of you guys doing? We're all right here? What we're doing to, excuse me? Well, he typed them in. Did you type them in? Do you have the graph in front of you? Okay, well then that's how we got the answers. I told you to put them in Desmos. What do you think that thing is just sitting there open for the heck of it? He must have went ahead while I was going, which is fine. It's fine. I don't know why it's such a big deal, period. Yeah, that's not something, yeah. These will be the first, I think, 2 or 3 on your homework today. Your homework, I think, is 5 problems. Yeah. I want to make sure, Dalton, you're okay. Does the graph is good? Okay. So the whole point of today is knowing what you're looking at on the graph. We know we're looking for their intersection because I have 2 equations here. Fair enough? Go to the back. Now we're in some situational problems. How many equations do I have in this problem? Just one. And do you see how they give it right there to you? What kind of equation is this? So if it has a squared in it, what kind of equation is it? Quadratic equation. Okay, highest power is 2. Now, please notice that these have h's and t's. I would like you to change them to x's and y's. Everybody doing okay there? First thing I want to know is, what does a t or the x stand for? Seconds. And what does the h or the y stand for? Height. So go ahead and put that in your graph, please. And you should be getting a parabola shape because we know this thing is quadratic. Type it in your equation, please. Thank you. You have to put y equals. You have y. Yeah, we're seeing it. Oh, you're fine. Just zoom out a little bit. Yeah, it's just really skinny and really tall. 16, 65. Is it plus 65x? And then plus 1? Okay. All right, so here is my parabola. Okay. First question asks you, what is the maximum height of the ball? Maximum happens at, what is this point up here called? The vertex, and we say it's 67 feet. We do round, yes. Thank you, ma'am. Derek, did you have a question for me? Because they asked the maximum height, and if you look up here, t was seconds and h is height, so that would be the y. So that's why we're looking at the y one. How long is the ball in the air? So here's my ball. This is where it starts. This is where it ends. So we're going to call that 4.1, and this is seconds. Okay. Approximately how high is the ball after 1 second? So here is where we use our table. And after 1 second, how high is it? I'm not really sure. It's like, I'm not really sure. Hit the gear button right here. And there should be one that looks like a table that you could click on. So actually, honestly, after this, you might be able to do some of what you couldn't do earlier. Okay. Everybody okay with this 50? It is, because it's a y, remember, a height. Now, this one's a little bit different than what we've done before. After how long is the ball 60 feet high? Folks, is 60 feet high an x or a y? It's a y, because height is where the y is. So if I'm looking here, I want to find where the y is 60. Well, right there is where the y is 60, correct? So if I was going to estimate this, what would I say? Well, I only want one decimal place. 1.4. Is everybody okay with that? But folks, it hits that on the way up, doesn't it? And then it hits it on the way, which is over here. So you told me 1.4 for that side and 2.7 for that side. Is everybody in understanding on why there's two answers to this problem? Hits it on the way up and hits it on the way down. Okay. All right, let's try another one. Again, I ask you, how many equations do we have in this problem? Just one. And what kind of an equation is it? It's quadratic because that highest power is 2. Go ahead and turn those into x's and y's, please. And get it on your graph. Just X it out. They aren't parallel, but this thing is super, I think it's a rocket, isn't it? It's going straight up into the air and almost coming straight back down, to be honest. Yes, sir. Oh, I thought you were raising your hand. I apologize. So, how are we doing with the picture? Good. Okay, first question asks you, how high will the rocket fly? 976.6. And this is feet. How long is the rocket in the air? That would be when it hits the highest point. 15.6 is when it comes back down to the ground. Remember, this x-axis acts like the ground here. So 15.6, excuse me. Excuse me? Yeah, I know. How high is the rocket after 15 seconds? So you're going to your table, and we're typing in a 15 because there isn't a 15 here. So I'm going to click on that, and I'm going to type in a 15, and that's where Dalton is getting the 150. Okay, last question for this situation. After how long is the rocket 120 feet high? Is that an X or a Y? That's a Y. So we're going to go to 120 on the Y axis. Now, you might have to move it and zoom it to find yourself 120. Right here's 120 for me. I'm going to estimate that at what? 0.5. That's on the way up. And on the way down, 15.1. So 0.5 and 15.1. Wonderful. Anybody having any questions on these situational problems? Nope, we're going to do last one right now. We have plenty of time. Okay, so again, I'm not looking for intersections because there's only one graph, yes? And I'm not just looking for the x-intercept because we're asking all these different parts and pieces to this problem. It's not just asking you for a solution, okay? This one already has x's and y's in it, so go ahead and put it in. Do what again? Oh, I know, they're large. Is it plus 135? Yeah. Because that's the constant of gravity. So whether you know it or not, if you drop a tennis ball or a bowling ball from the same height, they're going to hit the ground at the same time. That's for meters. This is in feet, so that's why it's 16. Yeah, that's why it's always a negative 16. Because we're in feet. If we were in meters, it would be negative 9.8. Is that okay? Oh, yeah. Well, you don't have to remember them for me. I'm always going to give you the equation. Okay. First question, how high? Shouldn't be negative. How? 284.8. Okay. How long is the rocket in the air? Over here. Now, that's how long it takes to get to the highest point. It says, how long is it in the air? There you go, 8.4. Notice how it was double what you told me, Dalton? Because it takes half the time to get to the top and then half the time to get back down. How high is the rocket after 6 seconds? So here's where our table comes in. 34. Last question. After how long is the rocket 260 feet high? Well, I'm going to zoom in here. See if I can find me a 260. There it is. About 3. 3. And how about over here? Is it 4 or 5.5? Yep, 3 and 5.5. Come on. It's not difficult as long as you know what you're looking at on the graph. On Monday, you will have review. On Tuesday, you will have a quiz. Then for the rest of next week and the following week, I have one more unit to cover with you. And then after that, we're going to start your test prep for your math test. Okay? Any questions for me before I give you your homework? No? Okay. Your homework is... You might as well just leave your Desmos right in front of you there. Yeah. And honestly, though, Derek, if you try those other assignments, you might be good now. So we talked about that. You might take a lanyard, please.